This lesson is going to teach you how to, one, recognize an ionic compound, and also how to take the name of an ionic compound and to write the chemical formula. So before we start, I want to just have you look real quickly at this periodic table. And it's important that you remember where the stair-step line is, and also that metals are on the left and nonmetals are on the right. In addition to remembering this information, I also want to quickly review the charges of the columns because you're going to need those today. Group 1, the alkali metals, have a +1 charge. The alkali earth metals have a +2 charge. And then we're not going to worry about these transition metals in this little area under the stairs right now. We're going to come back to that on another tutorial. So we're going to hop all the way over here to the halogens, -1, and backing up, -2, -3. Also remember that aluminum, zinc, silver, and mercury are exceptions. Aluminum is always +3, zinc is always +2, silver is always +1, and mercury is always +1. I tell my students to remember 3, 2, 1, 1. Right there's your little pattern, and they're always positive because they are metals. So you may want, if you've got a periodic table out in front of you and you've got these labeled, you may want to keep that handy as we go through and do this tutorial. A couple things I'm going to tell you real quickly, and I'll put these notes back up at different points so that you've got a chance to pause the video and write some things down, and I encourage you to do that. You know that you have an ionic compound when you have a metal and a nonmetal. You could think left side of the periodic table, right side of the periodic table. You could also think in terms of cation, anion, positive, negative, and keep in mind these might contain a polyatomic ion. Now I'm hoping at this point, if you're not one of my students, you have been introduced to the polyatomic ions. I can put those up later and just make sure you know what those are, but I'm talking about things like sulfate, nitrate, hydroxide, those really common polyatomic ions that show up especially in this beginner chemistry course. So what we're going to do is we're going to take the name, and I'm going to teach you how to take that name and how to write the formula. And here are the 3 points I want to focus on right now. We're always going to write the cation and its charge first. That means we're going to write the metal and its charge based on its column of the periodic table. And then we're going to write the anion and its charge, which is going to be negative second. And those are going to be from your nonmetals, and you know those charges from the columns of the periodic table. Then we're going to do this really technical, just really important step called crisscross. And literally that's going to take care of everything that we need to do. It is so easy. So that said, I do want to show you something real quickly before I start getting into these formulas. So I'm going to go ahead and look at this first one. We're going to be working with magnesium chloride first, but before I officially do these, I just want to show you something. So we know that magnesium has a +2 charge, and that's because it is in column 2 right here of the periodic table. That's how I know it has a +2 charge. And we know that chloride has a -1 charge, and we know that because chlorine is in the halogen column, which has a -1 charge. So literally, I cannot stress this enough, you know the charge based on the column it's in. And they're really easy to remember, but you can always look at your periodic table for now if you need to. Now, if you were Mother Nature, this would be what you would be thinking. You would say, okay, how can I combine these two atoms so that when they're combined, I have an electrically neutral molecule? Like, what is the smallest whole number ratio I can put these things together in so that I have a net charge of 0? And so Mother Nature says, okay, magnesium has a +2 charge and chlorine has a -1. It would kind of make sense if I would put 2 chlorines, -1, 2 chlorines with 1 magnesium, because this has a +2 charge and these two together have a -2. So maybe I should put 1 magnesium with 2 chlorines, and now I have a neutral compound molecule, however you want to refer to that. And that makes sense, because if magnesium has a +2, that's kind of a total of +2. If you have 2 chlorines and they each have a -1, 2 times the -1 is a -2, those cancel, so we are neutral. That is what's going on in the background. Okay, that's running in the background when you do this crisscross method. So it's important you understand that and why we're doing it. But crisscross is going to take care of all of that for you. So that makes it super simple. So that's the whole point of what we're getting ready to do. So this is the fun part. This is one of my favorite things to teach. I just think it's fun. It's very satisfying when it just all works out. So I'm going to be showing my work for all of these. And as beginning chemistry students, you should also be writing these down. But very, very quickly, you're going to get to a point where all of this is just happening in your head, because you're learning to read and speak the language of chemistry. So number 1, we just did this. I'm going to be quick with this. We know magnesium has a +2, so we wrote the cation and its charge. We know chlorine has become chloride, and chloride has a -1 charge. So literally, when you crisscross, if you could get your hands on that 2 and that 1 and just grab them, you are picking them up and you are switching sides and coming down to the bottom. So you're grabbing that 1 and you're putting it right there. You are grabbing that 2 and you are putting it right there. We don't write 1s as subscripts because they are understood. So it's going to be Mg, understood 1, Cl2. And that is our answer. That is literally all you do. So simple. So remember, you're only, think about it in your head, you are grabbing these numbers right here, not the charges. I just want you to think of the charges as like poof, they're gone, they're magically disappearing. I've already shown you how Mother Nature takes care of that. So you literally just grab those numbers, switch sides, and put them on the bottom. Now, once you've written your chemical formula, a couple things I want you to notice. You will never have numbers up here. Those are gone. You will only have subscripts on the bottom. Again, we do not write 1s. And when they're on the bottom, no charges on the bottom. It is just simply a number. And honestly, if you were to write this as Mg1 Cl2, that's probably just going to look a little weird to you at this point. So you know that this is wrong. That is not how we do it. This is going to be the correct answer. So let's look at number 2, aluminum oxide. So aluminum is one of the exceptions that we have memorized, and it always has a +3 charge. And if you'll remember, that comes from those 4 exceptions that I showed you, 3, 2, 1, 1. So aluminum has a +3. Oxygen is in the -2 column right here. So oxygen has a -2 charge, so O -2. We are going to grab the numbers. We're going to put that 2 right there, that 3 right there, crisscross. So our formula is Al2O3. And that's it. Let's do the next one. Calcium nitride. So calcium has a +2 charge because it is in the +2 column. Nitride has a -3 charge. So we're going to write calcium symbol +2, then we write the nitride symbol -3. Again, I want you to notice we are always writing the metal first and the non-metal second. Grab that 3, just plop it right there beside of the calcium. Grab that 2, plop it beside of the nitrogen, and we have Ca3N2. Boom. How cool is that? And it's so easy. All right, let's do number 4. Barium sulfide. So when I look at my periodic table, barium has a +2 charge, and sulfide has a -2 charge. So barium, Ba +2, sulfide is S -2. Again, writing the cation first and the anion second. Now, this one's a little different because these have the exact same number. They are going to cancel each other out. So what Mother Nature says is, well, that's just going to be a 1-to-1 ratio. So like charges just cancel. You just cancel them out, smack them together, and you've got BAS. That's it. So that's a little something for you to remember. And on the notes page, I think I've written that down. Like charges cancel. And we could let's just make a note of it. Like charges if you're like me, you think, oh, I'll remember that, and then later you don't. So now we have a note of it. All right, let's do number 5. Calcium oxide. So calcium has a +2. Oxygen has a -2. So calcium +2, oxygen -2. Once again, the 2's cancel, smack them together, CaO. Just like magic. And again, those charges, poof, they're gone. Don't worry about them. Now, at this point in the video, I'm going to do the rest. You may even want to pause it and try the next 3 yourself. Just see how you do. And then pick back up and go back through and double check with me. That's going to be a great way to assess yourself and see if you're ready to move on to the next step where we're going to add some polyatomic ions in. Right now we're just working with binary ionics. So zinc chloride is Zn +2. Chloride is Cl -1. I feel like all of you know where to get those charges now from the periodic table, so I'm not going to keep putting that up there. The 1 comes down, the 2 comes down, ZnCl2. Remember, ones are understood. Silver chloride. Silver is, I will pull the periodic table out for this because silver is one of those exceptions. Remember our 3, 2, 1, 1 exception. Silver's right here, always a +1. So silver is +1 and chloride is -1. The ones cancel and smack them together, AgCl. I love putting boxes around my answers. Just shows me, hey, I'm finished. Looks very officially done. And the last one, sodium phosphide. Sodium has a +1. Phosphide is P -3, and we haven't looked at that one yet on this tutorial, so I'm going to show you. P is -3. Don't get that mixed up with phosphate. I'll talk to you about that in a little bit. So phosphide is P -3, and when you crisscross, you get Na3P. So that is how you write the formulas for binary ionic compounds. And again, binary just means a metal plus a non-metal. Now we're getting ready to get into a lesson on polyatomics, but this is actually the perfect place to show you why knowing your polyatomics is important. And if you're one of my students, I know you've heard me say this 10 bazillion times. Let's say that I were to give you sodium phosphate. Looks pretty similar to sodium phosphide. I mean, you've just got this little ending here. This is why it's so important you know these polyatomic ions, because if you write this one, again, sodium's a +1, no problem. But phosphate is not an element. Phosphate's a polyatomic ion that you need to be able to recognize really quickly. And that is going to be PO4 -3. We're still going to crisscross the same way, and that's going to be the next step. but it's going to be Na3PO4. So there's a big difference between Ide and 8. And that's, for some of you, that might just have been a big aha moment, like, okay, I see why my teacher's nagging me about that all the time. Super, super important. So again, if you haven't done so, I cannot emphasize enough, memorize those polyatomic ions. It will make your life so much easier. You don't want to have to look them up every single time you need them. Now, that said, let's take a look at how we deal with polyatomic ions. Let's transition over here. Now, a couple things. Let me grab my notes for a second. I told you I put these back up so that you could look at them and maybe pause. When we are dealing with polyatomic ions, I want you to remember what I like to call the 3 Ps. Protect the polyatomic with parentheses. I was not even attempting to write that. I'm pretty sure I misspelled it. No spell check when you're handwriting. So anyhow, protect the polyatomic with parentheses. You still have no charges in your formula. There are no superscripts in your formula. Everything else is the same. But when we see a polyatomic ion, what we're going to want to do is imagine putting a shield around it, because you don't want anything touching that ion. Again, you're only manipulating the charges and moving those down. Everything else is exactly the same. So let's look at this first one, aluminum nitrate. We already know that aluminum has a +3 charge, but we know nitrate is not an element. Nitrate is a polyatomic ion, NO3 -1. Now, the 1 is still going to come down here, just like you've been doing. It's just the only difference is instead of an element, that's a polyatomic ion. We're only working with this charge. And the 3 is going to come here. But here's what you've got to be careful about. And I know I'm probably going to run out of space, so let me find a little piece of scrap paper here to write this on. So if you're writing in an ink pen, you've probably got a little more room. The Sharpie's just so fat. If you write it this way, AlNO3, and you bring the 3 down, I'm hoping that just looks really strange to you, like something is wrong with that. What, a 33 subscript? Don't think I've been seeing a lot of that. So what you want to do is you want to protect that polyatomic, just wrap it up in some parentheses, and this 3 is going to come outside of the parentheses. That looks a lot better. So I think it's just as important for you to see the no-nos as it is for you to see the way it's supposed to be, because that's going to teach you to know what looks right. So I would encourage you to jot that down and put a mark through it. The reason it's wrong is you didn't use the parentheses. So let's look at the next one, zinc sulfate. So zinc is Zn +2. Sulfate is SO4 -2. Just like we did on the binaries, if the charges are the same, cancel them out and literally just smack them together. So you have got ZnSO4. Let's put little boxes around these two. Now, a lot of kids will say, well, what if I don't want to cancel those out and I decide that I am just going to leave them? Don't do that, because when you're doing a bigger problem, that is going to maybe mess up your molar mass. If you're, maybe doing a limiting reactant problem or something like that, your balancing is going to be off, your mass is going to be off, your molar ratio is going to be off. So again, I would encourage you to make a note here to remind yourself not to do this. If they can be canceled, they have to be canceled. And always do the canceling before you crisscross. That is very, very important. So cancel up high and then bring the numbers down low. All right, next on the list is calcium permanganate. That's a mouthful. Calcium is Ca+2. Permanganate is polyatomic ion, MnO4 -1. That's one of my favorites. I have no idea why, but I love writing that one. So bring the 2 down here, the 1 down here. So your answer is going to be Ca parentheses MnO4 close parentheses 2. And there you go. 2 goes outside the parentheses. Do not write the 1. All right, sodium hydroxide. Sodium is Na plus 1. Hydroxide is OH minus 1. The 1s do cancel, so you get NaOH. And you know what? While I'm doing this one, there is something I would like to, just a little extra something I would like to tell you about. Let me grab another piece of scrap paper here. This one sometimes causes some confusion with students, so let me just address something else while we're talking about hydroxide here. Let's say that you had calcium hydroxide. Calcium has a +2 and hydroxide's a -1. Another misconception with a lot of students is when you crisscross these, I know that's a polyatomic ion, but since there aren't any subscripts, a lot of students think it's okay to write it like that because you're kind of thinking, I don't really need to use those parentheses because there weren't any little numbers down here. That is actually incorrect. You have to put parentheses around that polyatomic ion regardless of if it has any subscripts. Always protect it. So the right way to write this is going to be CaOH2. So this is the way you want to do it. So even if your polyatomic ion does not have subscripts, I don't care what the polyatomic ion is, wrap it up in parentheses. There's one exception to not using parentheses, and that is if the number you're bringing down beside of a polyatomic ion is a 1, you don't write 1s, so you don't need parentheses, but the rest of the time you do. All right, let's look at barium chlorate. So barium has a +2 charge. Chlorate is ClO3 -1. Crisscross, bring the 1 down here, the 2 down here. Ba ClO3 2. Protecting the polyatomic ion with parentheses. Listen, if you can remember that, this is a piece of cake. All right, aluminum dichromate. I can already tell I'm probably going to run out of room on this one. Aluminum is Al plus 3. Dichromate is Cr2O7 -2. Big old polyatomic ion there. So we're going to crisscross. 2 comes here, 3 comes here. The answer is Al2. Now wrap that thing up in parentheses. Cr2O7. 3 goes on the outside because it would have looked really odd to have O73. And I think everybody would have picked up on that really quickly. There's your answer. Now, if before this lesson, if you would have seen this, you would probably not have had a clue what it was as far as naming it, especially if you didn't know your polyatomic ions. Like, students could get really creative on some naming with this. But literally, I see aluminum and I see dichromate. And you're going to learn in the next tutorial, that's simply going to be aluminum dichromate. So some of you may have already kind of picked up on that. All right, next is ammonium phosphate. Now this one's a little unique. Most of our polyatomic ions that we work with are negative, but there are some positive ones out there, and ammonium is one of them. Ammonium is NH4 plus 1. Now I know I keep saying always write the metal first, but really what you're writing first is whatever's positive. And in some cases that will be a polyatomic ion. This is one of the only ones you're really going to see at this level of chemistry. Phosphate is PO43 negative. Looks messy. Just simplify it. Really, that's kind of one whole thing. That's kind of one whole thing. You're really just worried about these charges. So the 3 is going to come down here, but because I'm putting that 3 beside of a polyatomic ion, I'm going to end up wrapping that thing up in parentheses. The 1 that's coming down here is actually not written because we don't write 1s, and that is the exception where I'm not going to have to use parentheses. So it is going to be NH4 in parentheses. That 3 is outside, that 3 that came down here, and then just PO4. Again, we're not going to write PO4 in parentheses and put a 1 on the outside because that's just not how we do it. So this would be the wrong way of doing this one. You don't want to do it this way. That's what we don't want to do. So again, good time to pause. Make a note, you know, if you've got a 1 coming down, the parentheses are not necessary. And for some of you, you probably immediately said, that just looks wrong. So you get used to this and you get so much better with practice. I'll probably do some more tutorials, just mixing all of these up once I've taught them all. And I promise you, if you practice, you will get better and better, and it will happen very quickly. Last one, lithium iodate. Lithium is Li+1. Iodate is IO3-1. Don't get that mixed up with iodide. The 1s cancel, and we get LiIO3. So what you've learned, whether you're working with a binary ionic compound or you're working with an ionic compound that has a polyatomic ion in it. Either way, really all you're doing is you're just crisscrossing. You just have to remember a few exceptions, and those exceptions are don't write the 1s, and I said I would put these notes back up, so I'm going to put these up while I talk. Don't write the 1s. If you have a polyatomic ion, make sure you put parentheses around it, and like charges always cancel. Make sure that you don't put any charges in the formula, for example, and I'll write this down real quick too. You know, I'm all about the overkill here. If you say it once, 5 times is even better. So, for example, it would look weird to see in a -2 O+1. Those charges down there, again, they look busy. They look weird, excuse me, not what you want to see in a formula. And also, you never want to have anything like this. You don't want to have any kind of superscripts in your formula. So these, hopefully, again, look weird to the eye. So you'll know not to do that. The next tutorial is also on ionic compounds, but I'm going to give you the formulas and we're going to write the names. That one's a lot shorter simply because it is a lot easier. We'll do binary and the polyatomics in the same lesson. So this is the first video that you should watch in naming, and I'll put that in the introduction, and then we'll do them in order so everything flows.